What are you with me? Nitakuwa me tamu.
The X6 plus, please kindly mute yourself.
Ronge yako sema sina mente hivi say nima. Ase.
Galaxy A6 plus. You can't mute yourself, or
Wow. Okay. Then the next disorder that can happen within the ventral pathway is visual agnosia. You remember I said with the ventral pathway, when someone wants to recognize an object, it doesn't only go to the area V1, it needs to also go to the temporal lobe. So it means when there's what? There's any lesion or damage within the temporal lobe, it's probable that the person might suffer this type of disorder known as visual agnosia. Visual agnosia. And in visual agnosia, the person wouldn't be able to recognize certain objects. This time around, it's not face, but objects. Like, okay, the gadget that you are using at the moment. Someone who has visual agnosia, the moment you show him that kind of object, it will be difficult for the person to recognize. Okay. So in most situations, they can easily give vivid description. Okay, they can tell you, oh, this laptop is rectangular in shape. It has some letters and all that, or alphabets and numbers, blah blah blah. They can give you full details of the object. But when you ask them, so what is this? They wouldn't be able to recognize and tell you this is a laptop. All right. Then another disorder that can happen within the ventral pathway is something known as motion blindness. Motion blindness. So if you remember, I told you when it comes to motion, perception of motion, the temporal lobe also plays an important role. So when you visit movies and all that, you can see that, oh, you could see there's a motion happening, right? Someone who has motion blindness, they wouldn't be able to perceive movement of objects. So to them, they feel that everything is stationary, everything is static. So it causes a whole lot of disturbances in their life. Seriously. Why? Because even crossing the street becomes difficult. Why? Because they wouldn't be able to perceive that, okay, how far the car or the vehicle is. So they wouldn't be able to perceive that. Okay. And also with, let me turn your mind back to the prosopagnosia. Prosopagnosia patients who have difficulty recognizing faces, they also have difficulties even watching movies. That's one thing. So in most situations, when they are watching movies, they see all the faces as what? As the same. They see them as what? As similar. And in most situations with prosopagnosia, it could be genetic. Some people acquire it, or sometimes it runs in the family. Other times, people acquire it through accidents, that's traumatic brain injury, or stroke. Okay. So these are the things you need to know when it comes to the ventral pathway. So remember I said we have two main pathways. We are done with the first pathway. The next one is the dorsal pathway. The dorsal pathway. With the dorsal pathway, sometimes the information, when it gets to the area V1, it further moves to the parietal lobe. And you know where the parietal lobe is located at the moment. It further moves to the parietal lobe. So when you check the brain, so this area is the parietal lobe. So and this is the area V1. So when the information gets to the area V1, it further moves to the parietal lobe. When it gets to the parietal lobe, then it means there's a pathway known as the dorsal pathway. So you have it in your slides, dorsal pathway. So there are only one thing that moves to the dorsal pathway. So for instance, when you're trying to reach out for an object, okay, so you have maybe your laptop, you want to reach out for it and even take it or something. So for you to do that, it means the information needs to further move to the parietal lobe. All right. So please, any question when it comes to the dorsal pathway? Or before the question, let me explain everything in details. Then we'll be done. So when there's a damage within the parietal lobe, it means that the person wouldn't be able to reach out for certain objects. The person wouldn't be able to reach out for certain objects, and we call it optic aphasia. Okay. So please, any question when it comes to vision? So we are done when it comes to information moving from the eye to the brain. These are the things, the key things you need to know. Cyril. Okay, so please, any question? George. George, kindly unmute your mic and speak.
Hello, sir.
Yes, George.
With the motion blind, does it go with age?
You're saying with emotion what?
Blind or visual blind, visual blindness. Does it go with age?
In most situations, as you grow, fine. It could be that yes, certain things could happen because as we grow, our tissues also weakens a bit. Okay, so if that happens, then it means that it could maybe cause some lesions or disruptions within the temporal lobe, especially the medial temporal lobe, leading to motion blindness.
Okay.
By most situations,
okay.
that expedite on this is when you suffer stroke. It could cause a lot of disruption in that area, or you get an accident. Yeah. But
sir.
Yes, please.
Okay, George.
Yeah. What about
okay.
a young boy, a young boy who has a blurred vision? What about that one too?
George,
a young boy between the age of 15.
Blurred vision has nothing to do with motion blindness. Blurred vision could be that okay, the person has some defect within the eyes. Okay, but with motion blindness, the issue has to do with the brain. There's a lesion or damage within, especially the medial temporal lobe.
Okay, sir.
That.
All right, sir. Thank you.
You're welcome. Okay, Bar.
My question has to do with the recognition of the person's ability to recognize this is maybe say the laptop or the shape.
Yeah.
But cannot be able to communicate or be able to say this is really a laptop, but you'll be able to see whatever is there, that object.
Yes,
so is it that it's a bridge of communication between the Hello?
Yes, I can hear you. Continue.
So what normal causes that? Is it that there's no hello?
Go ahead, Bawa.
Is it that there's bridge of communication? There's no proper communication. That's why it happens.
Yeah, you know, for you to
because I had a friend. You know.
Okay. Tracy, kindly unmute. Kindly mute yourself. Tracy, you'll say. Okay, Bawa, continue. I want you to end before I answer.
So I'll say a friend of mine experienced this. Okay. He was able to recognize the initial one that I asked. Ability to recognize the Agnosia, the ability to recognize objects by inability to recognize faces.
Okay.
And then it was perceived that he was using a particular glass.
Okay.
So that was what led to him developing this problem.
No.
So I want to know with this with the visual agnosia, can it also be caused by maybe other things rather than stroke and maybe accident, or it can just happen?
Nope, it wouldn't just happen. And the prosopagnosia, are you telling me that the person was using glasses that led to that. It will never.
Yeah, he was using a particular glass. Yes.
No, it will never. It will never
Okay.
lead to that. All these
Okay.
visual deficits is either it is through genetic or through accident or
Okay.
stroke. Then something, yes.
Okay.
So if old age
Okay.
too, then fine. It could be possible.
Okay.
So
All right.
in most situations, for there to be any sort of lesion, then it means that the person was what? Had stroke, accident, or through
Okay.
age. But with sometimes you can scan the person's brain and you can see that okay, nothing or whatsoever. There's no lesion or whatsoever. Sometimes it is
Okay.
due to what? Due to genetics leading to that.
Okay.
Yeah. So
Okay. Okay. All right.
basically,
All right.
that's what it is all about.
Okay. Okay.
All right.
All right. Thank you.
You're welcome. Daniel,
Yes, sir.
please go ahead.
So please, sir, yeah, the point under the optic aphasia or aphasia,
Okay.
it's not really clear to me. Are you saying that the person will know that the object is there, but could not be able to reach or move towards the direction of the object, or
Yeah, they wouldn't be able to move towards the direction of what? So this is what happens. You have maybe a laptop here, okay? In most situations, you can see it and all that, okay? And reach out for it and even what, pick it, okay? So with them, they have difficulties moving to that direction to what, to reach out for it and pick it. Sometimes they will miss the direction of what, of it, of where the laptop is located. It's not that, okay, their limbs or something is what is damaged, but they have difficulties reaching out for it, locating it exactly. So the thing is stationary, it's not moving. Okay, the object is stationary, it stands still. You can easily what, direct your limbs or your hand and reach out for it and grabs it. But to them, in most situations, they will miss the direction of it and wouldn't be able to reach out.
even though they can see and
Yes, they can
identify
see.
the object.
Perfect, yeah. But when someone picks the object, okay, and put it on their maybe hands or something, they can easily handle it well.
And
but them reaching out for it, they mostly miss the location of it.
Wow.
Yeah.
And this is not to say it's a total blindness.
No, when you say total blindness, blindness has to do with conscious vision. The area V1 is the one responsible. So the area V1 is located within the occipital lobe. That is intact. So the person can easily see the object because the area V1 is not damaged. Right? When I say the area V1, it's the same as the primary visual cortex or the straight cortex. It is not damaged. So the person can easily see it. But the other structure within the brain that should guide the person to reach out for the object, there's a lesion, there's a damage. So it means the person can easily see the object, but will have difficulties directing his or her hand to reach out for that object in the first place.
Okay. So what about maybe, can the person be able to calculate the distance between where he is sitting to the position of the object, or that one to become very difficult?
It becomes difficult because for you to make any calculations or whatsoever, that would guide you to reach out for it. So that's what we are saying, because the area within the temporal lobe responsible for helping you to make those calculations and reach out for it, it's not really intact, then definitely the person will miss it.
All right, sir. Thank you.
You're welcome. Okay, Emmanuel, Emmanuel, kindly unmute yourself and speak. Could you? Yeah. Emmanuel. Yes, go ahead.
Please, I want to get. Yeah, hello. Yeah, hello, sir.
Please go ahead.
Please, the optic aphasia and the motion blindness. Yeah, what is it?
Good. I like that. So,
yeah, between the two.
Good. So remember I said with the optical aphasia, the object is stationary, means that it's not moving, right?
Okay. Okay.
Or with motion blindness, it has to do with motion. It is moving. So for instance, you are watching a movie. There's movement. The person sees these movements in a very slow motion, very, very slow.
Okay.
So that's why I use an example where maybe there's a car coming, okay? You want to cross the street.
Yeah.
Someone who has motion blindness will have difficulties crossing the street because they wouldn't be able to calculate or even perceive that, okay, this is where the car has reached. Because they have, to them, they see the car as as standstill or even coming slowly.
Moving slowly.
Exactly.
Okay.
So if care is not taken, they can easily it could
knocked by the car.
Yeah.
Okay.
They can easily be knocked by the car. Yeah. Okay.
Thank you, sir.
You're welcome.
All right.
Lord.
Yes, sir. So my question relates to the motion blindness.
Okay.
Yes, sir. When someone has a condition of seeing moving object in a snapshot, they just see it here, the next second, you don't know when it got to the other state, like that kind of visual difficulty. Can you relate that to motion blindness?
Yeah, that's what I'm saying. Yeah.
Okay, I think, all right. I thought you said they will only see it moving slowly, but not as the normal speed at which the object actually moves.
They wouldn't see it as a normal speed. It comes in snapshot. Like sometimes it comes slowly or even like snapshot and it delays. There are a lot of delays in it.
All right, sir. So okay, so when talking of snapshot way of seeing the object as a deficit in visual problem to somebody. So I'm asking is a question, follow-up question. With the motion blindness, can we relate the malfunction of the reticulum activation system to it?
Please don't go there. Nope.
It's a different problem.
Yeah.
Okay.
So as I said, it is about the medial temporal lobe. There's a damage within the medial temporal lobe causing that.
Okay. Okay. Thank you.
You're welcome. Okay, so the last person, Cyril. Cyril, again, we can't hear you. So Cyril, please, you can go to the chat room section and type. I would answer. Say, can you please go over blind disorders? So Cyril, you want me to go, because most of your colleagues have been asking questions related to that. So I believe by now you should get it. If you have difficulties, Cyril, I'll make sure that the link to the YouTube is what is available. So you can visit my YouTube channel and watch it. You'll get everything, okay? All right. So the next one that we'll be doing is the ears. So we are done with the eyes. We're moving on to the ears. So like what I did for the eyes, the ears is also self-explanatory. Okay. So in most situations, we have three main things: the outer ear, the middle ear, and the inner ear. So the outer ear is what is referred to as the pinna. Okay. So the pinna will be the one to collect sound. Then later it will move it to the middle ear. The middle ear contains three main structures. Okay. And we call, let me annotate. Where is it? Yep. So where is it? Good. So the middle ear contains these structures. Known as malleus incus sticks, or another name for the three structures are hammer, anvil, stirrup. Okay, so they are fibers known as ossicles. They are known as ossicles. The three structures, malleus incus sticks. All right. Okay, so these are the things you need to know within the ear. Then afterwards, it will then move it to the inner ear. Within the inner ear, we have a structure known as cochlea. Okay, so the cochlea will receive it and move it to the later to the brain for interpretation. So my main focus when it comes to this side is what happens within the brain. That's the main focus. Because with these, they are self-explanatory. Okay, so let me stop sharing this and move. So within the cochlea, as I said, the cochlea will be the one to receive the information, and like what we did for visual information, the sound energy needs to be converted. It will be converted into what? Into electrochemical energy. Same transduction. Then it would then be carried into the brain. So first, the cochlea will move it to the lateral lemniscus. So the lateral lemniscus within the brain, especially it is located within the brainstem. They are the ones that will receive the information first. So I'm repeating. The cochlea, which is found within the ear, would transfuse the information from what? From sound energy to electrochemical energy. Then it would move to the lateral lemniscus found within the brainstem. So the lateral lemniscus, it serves as a relay station within the brainstem, meaning that it would project the information further to the inferior colliculus. So Zoom just alerted me again. I have 10 minutes. So when it cuts, use the same link to join. So the lateral lemniscus, which is the relay station, will further move or will project it to the inferior colliculus. So my question, right now, you know, within brainstem, I indicated to you during brain and behavior that we have two main things, the inferior colliculus and the superior colliculus. So what's the function of the inferior colliculus? What's the function of the inferior colliculus? Oh, please, let's be snappy about this. Please, if you have an idea, just use the image to raise up your hand, and I'll call you. The function of the inferior colliculus. Wow, nobody has an idea. Okay, then let me go ahead. I wouldn't explain because I've already done this when we were doing brain and behavior. Okay, so within the auditory system, in most situations, the inferior colliculus would make sure that it would integrate different sound energies, okay? Then those sound energies, it will be able to what? It would make sure that it will filter out the necessary ones because internally you are breathing. So there's what? There's sound, okay? It could be that maybe you are also chewing, there's also sound. So it means the inferior colliculus will make sure that it will filter out the most important ones, the information that you are paying much attention to, and neglect what is going on physiologically within your body, the sounds going on within your body, so that you can have conscious attention on that. All right. So when inferior colliculus filter out these sounds, it will then further move it to the thalamus. It will then further move it to the thalamus. And within the thalamus, we also have a specific region which is solely responsible for auditory information. So if you remember with vision, we said that within the thalamus, we have a specific region solely for vision known as the lateral geniculate nucleus. But when it comes to auditory information, within the thalamus, we have a specific region known as medial geniculate body. So they are the ones that will receive only auditory information. Then the medial geniculate body will project the information to the higher cortex. And the main cortex within the temporal lobe that will receive that kind of information is the Herschel's gyrus. So within the Herschel's gyrus, it contains the primary auditory cortex you know of. And per brain and behavior, our discussions, I indicated that the primary auditory cortex is responsible for conscious perception of what? Of auditory information. So these are the steps that happen. And for you to comprehend or understand the auditory material, it further moves to where? To the planum temporal. The planum temporal contains the Wernicke's area that you know, whereby we indicated that it is responsible for comprehension of speech. So it means if you are having discussions with your colleague, okay, you're having discussions. First, when the ear processes the information and the cochlea receives that kind of information, the cochlea will then do what? Will then transduce it from sound energy to electrochemical. Then it will move to the specific brain region, lateral lemniscus. Lateral lemniscus will relay the information to the inferior colliculus. The inferior colliculus will make sure that it will filter out unwanted sounds so that you pay attention to only the relevant one. Then afterwards, it will then be sent to the thalamus, a specific area known as medial geniculate body. The medial geniculate body will then project the information to the temporal lobe, a specific area within the temporal lobe known as Herschel's gyrus. The Herschel's gyrus contains primary auditory cortex, also known as Brodmann area 41, which will then what? Help you to understand the the auditory material or perceive the auditory material. Aside that, since you're having discussions with your colleague, the material or the information needs to further move to the planum temporal, which contains Wernicke's area, so that you can understand the information what your colleague was saying. So these are the processes. All right. So please, any question? Any question? Emmanuel.
Lisa, can you share?
Please, can you go over again to the
Wow, I should go over again. Then it means that the latter part
terms are too much.
Yes, sir. I think we need a run over.
Oh, this particular one.
This particular one, you need me to go over, eh? Okay, I'll
Yes,
do
sir.
that.
Yes, sir.
I'll do that.
Because, like, from here to here, like from Lincoln to Ponglo to Tetekashi to 37, then we know that. That is it.
All right. I totally understand.
Thank you.
I'll try and repeat that. So please, I have.
Hello, sir.
Hello, Mary.
Yeah. Sir, please. Like my brother said, I would also wish you go over, but I wanted to ask a question.
Okay.
I want to find out if a question is asked concerning the process of how, let's say how sound is produced in the ear.
Mm-hmm.
Is this how we are going to put it, or there is another way to put it? Because
I said,
looking at the words,
okay.
Yeah.
When the question is put like that, they need to specify whether it is processed within the brain. Are they talking about how information or auditory information is processed within the brain? If it is about how auditory information is processed within the brain, then this is how you put it. Okay. But in situations whereby they are emphatic and say how is sound produced in the ear, only in the ear, then you talk about the fact that we have what? The pinna, the outer layer, your ear, the outer ear, we call it pinna. So the pinna will be the one to collect the sound information. Then it will later move it to the middle ear. Within the middle ear, we have the ossicles, malleus incus or hammer anvil stirrup. We normally say that it is the eardrum. So it would It would hit on on the sound energy and then further project it to the middle ear. It will then further project it to the inner ear. And within the inner ear, we have an area known as the cochlea. The cochlea will receive it because it contains some hair cells. So those hair cells will convert the sound energy to electrochemical energy, so that it will then be moved to the brain. Then you start from, so within the brain, this is the procedure. You start from the